we can label the different parts of an exponential or logarithmic equation and show how those labels get mapped between the two forms. The goal is to get used to converting back and forth between these two forms. Starting with an exponential equation. The value being raised to a power we refer to as the base of the exponential equation. The power of the base we call the exponent. What the base raised to the exponent is equal to we refer to as the result of the equation. Then, converting this to a logarithmic equation, the base of the exponent goes down here. This is the base of the logarithm. The result of the exponential equation ends up inside the logarithm. The entire logarithm is then equal to the exponent from the exponential equation. So we can use this mapping when converting an exponential equation to a logarithmic equation. Now, let's start with the logarithmic equation and go back to the exponential equation. For a logarithmic equation, the base of the logarithm is down here. The value inside the logarithm we refer to as the argument of the logarithm. What the entire logarithm is equal to is the result of the logarithmic equation. Going back to the exponential equation, the base of the logarithm will become the base of the exponential equation. The result of the logarithmic equation becomes the power the base is raised to within the exponential equation, also referred to as the exponent. Finally, the argument of the logarithm, what was inside the logarithm, is what everything else is set equal to within the exponential equation. When we go in either direction, the terms of the initial forms may be slightly different, but the mapping between the two forms stays exactly the same. Let's talk through two examples, one for each direction. Consider the exponential equation 3 to the 4th power is equal to 81. 3 is the base of the exponential equation. 4 is the exponent of the exponential equation. 81 is the result of the exponential equation. Now we convert this to a logarithmic equation. The 3 maps to the base of the logarithm. The 4 maps to what the entire logarithm is set equal to. The 81 maps to the inside of the logarithm. We've successfully converted from an exponential equation to a logarithmic equation. Now let's go in the other direction. Suppose we started with the logarithmic equation log base 5 of 125 is all equal to h. Here, 5 is the base of the logarithmic equation. 125 is the argument of the logarithmic equation. H is the result of the logarithmic equation. Converting it to an exponential equation, the 5 maps to the base of the exponential equation. The h becomes the power of 5. 125 becomes what 5 raised to the h power is set equal to. When starting with logarithms, it may be hard to determine what the logarithmic equation represents. This confusion should clear up over time when you convert back and forth between the two forms. For instance, solving for h when looking at the logarithm may be confusing at first, but after converting it back to an exponential equation, solving for h may be easier to understand when we're first working with logarithms. Looking at it as an exponential equation, we have 5 raised to the h power is equal to 125. So basically we're trying to find 5 raised to what power is equal to 125. Well, 5 squared is equal to 25. That's not right. So if we increase the power to 3, we get 5 to the 3rd power equals 125. This tells us that h is equal to 3. H equals 3 satisfies both the exponential equation and the logarithmic equation here. When looking at the logarithm, this h is essentially the power that our base 5 has to be raised to equal the argument 125. Essentially, the output of logarithms are powers that the base has to be raised to equal the argument. Now that we have gone over how to convert between an exponential equation and a logarithmic equation, we may be able to make more sense of some of the logarithmic rules and properties that were shown in class. For instance, consider the zero rule, the identity rule, and the inverse rule for logarithms. When looking at these rules for logarithms, it may be a little head-scratching at first, but if we convert all rules to their equivalent exponential form, it may be a little clearer why they are all valid. If these 3 statements make sense in exponential form, then in time their logarithmic equivalent form should make more sense. Hopefully you feel a little more comfortable converting exponential equations to logarithmic equations. For more videos related to logarithms, check out this playlist here. Support the channel by leaving a comment, liking the video, or subscribing. I'm Joe, and thanks for spending some time with me.